In order to maintain an equilibrium condition, rivers continually adjust their morphology in response to changes to their watershed or channel. These adjustments are relatively insignificant and occur frequently with little consequence, typically going unnoticed. However, severe and long-lasting changes to a watershed or river may exceed the river's capacity to maintain equilibrium through small-scale adjustments, and the river enters a state of disequilibrium, going through more severe adjustments that may persist for tens to hundreds of years before equilibrium is restored. The series of erosional and depositional processes that occur as the channel regains its equilibrium condition is referred to as channel evolution, and can be broken into 5 stages. In stage 1, the river is in equilibrium. The channel has the right combination of depth, slope, and roughness to generate the flow power required to transport its sediment load. The channel is also well connected to its floodplain, upon which it can spill and dissipate the erosive energy associated with high flows. Stage 2 of the evolution process is the incision stage, in which a change in the river or watershed results in increased flow power, causing the channel to erode its bed downward. This downcutting or incision of the channel results in still more capacity to contain flood flows, which in turn results in further increases in flow power and channel incision. In the example shown in the figure, the disturbance that increases the flow power is the berming of the channel, which traps flood flows and their erosive energies in the channel. Stage 3 of the evolution process is the widening stage, in which the river banks, having increased to a critical height due to the incision process, begin to fail, resulting in a widening of the channel and an increase in sediment inputs, both of which result in decreased ability of the flow to transport the sediment load. Stage 4 of the evolution process is the stabilizing stage, in which increasingly large bank failures result in increasing amounts of sediment input to the river, overwhelming the flow power and resulting in the development of large gravel bars that begin to narrow the channel. Stage 5 of the channel evolution process sees a return to equilibrium or stability brought about as the gravel bars grow high enough to effectively narrow and deepen the channel, creating sufficient flow power to transport the sediment load during moderately high flows and providing floodplains for energy dissipation during higher flows. The river is once again stable. The cost of the channel evolution process is long-term extreme river instability and associated hazards, and loss of land and any investments such as buildings and roads on those lands. Fish and other aquatic organism habitat and water quality are also significantly degraded by the evolution process.